Okay. Now let's excite one more electron. Jump one more electron. You will jump the electron from this is your 3s, 3p, 3d. Now how many unpaired electrons? You will jump this electron. This electron will jump here. So how many bonds? Gautam is already with final answer. He said 5 bond pairs and 1 lone pair. So this is how you have to make chlorine now with 1 lone pair and 5 bonds. So these 5 one of them can be multiple, doubly bonded. You can pair them, you can make a double bond. So this is how chlorine will appear. And what else? Can I excite one more electron, children? Yes, I can excite one more electron. If I excite this electron, then how many? No, you cannot. You can see that. Suniti, you can see that I cannot have 6 bond pairs. From 5 bond pairs, straight away I'm going for 7 bond pairs. So that's the limitation. So with chlorine, with this chlorine, bromine, iodine, you can have 1 bond with 3 lone pairs. You can have 3 bonds with 2 lone pairs, or you can have 5 bonds with 1 lone pair, or you can have 7 bonds. 7 bond pairs, right? No lone pair. So that's the limitation which we can understand. Is it okay, Suniti? Okay, great. You know, you heard about this perchlorate ion, ClO4 minus. You heard about it? Now you know oxygen can make 2 bonds. Chlorine can make maximum 7 bonds. So I can draw the Lewis dot structure like this. Chlorine in the center. I'll show you the rules also, but just what we are doing, I'm just trying to make you understand how this will become very easy if you think like this. This is the Lewis dot structure of perchlorate. Can you check how many bonds are there around chlorine? How many bond pairs? Count the bonds. 7. No lone pair. And how many around oxygen? 2. And 2 lone pairs. I was discussing about oxygen. We were making that box representation and checking how many paired, unpaired. It cannot have expanded octet. So you cannot excite electrons. So it's happy like this. Chlorine is happy, oxygen is happy. Like this. Right? So children, expanded octet is clear. Now let's see how to calculate the formal charges. If you remember P can make maximum how many bonds? Maximum how many bonds? How many valence electrons P has? So how many bonds it can make maximum? 5. It can have expanded octet. When P is making 5 bonds like this, how to check the formal charge? In the Lewis dot structures, every element is using its valence electrons. Every element. Only valence electrons are participating. The one which are in the outer motion. They are participating in bonding as bond pair and they are participating as lone pair. Agreed? Now, if P has given 5 valence electrons and if the Lewis dot structure is something like this, then how many valence electrons P has used here? How many? All 5 in making bonds. Every bond is using 1. So I count the bonds. I'll count the number of bonds and I'll check how many are used. So 5 are there. P has given 5 and it has used all its 5. Its formal charge is 0. Is happy. But if I give you P like this, can you check the formal charge? How many valence electron P has given? 5. How many electrons is using in bonds? Number of bonds are the number of electrons used. 3. How many electrons are there as lone pair? 2. 2 times 1. So, Aishwarya lone pair, they are also of the P only. So, what's the formal charge? 0. So, what is formal charge? It is the valence electrons given by the element and how these electrons are used in making lone pair and bond pair. No, Gautam, no. Check here. Formal charge, if it is 0, element is very happy. Element would like to have 0 formal charge in its Lewis dot structure or minimum formal charge. But we do have substances with formal charges. Like for example, all of you are going to answer this question. NH4 plus. Nitrogen is making 4 bonds with hydrogen. Can you check the formal charge on nitrogen? What's the formal charge on nitrogen? Use this equation. 5 minus 4 minus 0 is plus 1. So this plus charge is where? On the nitrogen. Can you check the formal charge on hydrogen? Sarayu, hydrogen, formal charge. Yeah, 1 minus 1. Shrestha, this is for hydrogen. Hydrogen valence electrons are 1, is making 1 bond, is 0. Remember I said hydrogen is always with 1 bond, that's it. No lone pair, nothing. Because it has only 1 electron, it can share 1 electron. There is no lone pair, right? Yes, yes, Kritana. But it can have a formal charge of plus also, very famous. This one is famous, H plus ion. But it's not in a bond. It's outside the bond, like free ion. But in a compound, in a molecule, hydrogen is always with 0 formal charge. Yeah. Okay. Sheshta is very, very wrong in what she is writing. Who is going to correct her? Sarayu, can you correct her? Shrestha is saying the valence electrons of hydrogen are 2. Is she right? Check the electron number here, Shrestha. Its number of electrons are 1 only. Then how come valence electrons are 2? 2 is for helium. You know the atomic number? Hydrogen atomic number is 1. Atomic number is the number of electrons, right? Elements are represented like this, Ca. The number periodic table is based on atomic number. This is the atomic number. The number of protons in hydrogen are 1. The number of electrons is 1. So electron configuration is 1s1. So its outermost shell is 1s1. So its valence shell is 1s1. So its valence electrons are 1. Yeah. Valence electrons are before bonding. Okay, so ready for the Lewis dot structure, children? Okay, I'm giving you this document again. If you have a printer next to you, you can take a printout and then we are going to use it. Okay. So how to draw the Lewis dot structure. Now, after understanding so many things, we are making Lewis dot structures of the molecules, ions. So we'll follow the rules. The very first rule is you're going to select the central atom. The central atom is always the least electronegative atom. There is exception. The exception is hydrogen and fluorine. They are never central atom. They cannot be central atom because hydrogen cannot make more than one bond. Hydrogen is always like this, singly bonded. Central element should be capable of making more than one bond. Only then it can be central. So hydrogen is never the central atom. Same with fluorine. Remember the fluorine electron configuration is helium 2s2 2p5. How many unpaired electrons you have? How many unpaired? Yes, please. Only one. So maximum fluorine can make how many bonds? Only one. Do we? Can I have excited state? Can I have electron in the d subshell? No, because there is no empty d orbital. So fluorine will be always with one bond pair. And how many lone pairs? How many lone pairs, girls? Yeah, three lone pairs. Yes, fluorine is always like this. Always. So whenever you see fluorine and hydrogen, the Lewis dot structure becomes very simple. Very, very simple. You need not to use your brain. Okay, every time you can draw it very fast. Okay, so and most of the Lewis dot structure are with fluorine and oxygen and hydrogen. Most of them. Okay, Srishta. So rule number 1 is clear. Now let's see rule number 2. You have to draw the skeleton. So I'm starting with one molecule, children. Let's start using these rules. So the molecule which I have selected is CF4. So the central atom is, yes, central atom is carbon. Now you're going to make skeleton. Skeleton means whatever atoms are present around it, make a single bond with all of them. There are 4 fluorines, make single bond. Rule number 2 is done. Rule number 3, count the total valence electrons. Total valence electrons in this CF4. How many valence electrons of carbon? Look at the periodic table. How many valence electrons for carbon? And for fluorine. So 4 for carbon and there are 4 fluorines. Each fluorine is so 4 times 7. How much is this? Now you have to use these 32 electrons to complete the octet of the most electronegative element. And who is that? Fluorine. And you know the limitation of fluorine. You know that fluorine is always singly bonded with 3 lone pairs. You know that? So just do that. Put 3 lone pairs on each fluorine to complete the octet. You can see that fluorine is with 8. And then check how many are used, how many are left. Check, this is 8, this is 8, this is 8, this is 8. So how many are used, how many are left? All 32 are used. Is anything left for carbon? No. So the carbon is carbon happy, children? Is carbon happy? Yeah, it is happy. It is with 8. It is with 8. 4 bonds. 4 valence electrons, 4 bonds. Carbon is very happy. And you cannot make more than 4 bonds around carbon because it cannot expand the octet. Maximum, it can make only 4 bonds. It is 2s2p, outermost shell. So this is the Lewis dot structure of CF4. Check the formal charge on every element. The formal charge on every element. Formal charge, use this equation. Fluorine is 7 minus 1 minus 3 times 2 is 0. Gautam is right. Same here, same here, same here. What's the formal charge on carbon, Sarayu? Formal charge on carbon is 0. 4 minus 4. Molecule is very happy, CF4. No formal charges. Ready for another example? So these are the rules which we have to follow. Remember, the number of maximum bonds an element can make is equal to its valence electrons, provided it can have expanded octet. Means after second period, this part. Ready? IO3 minus. Central element. Rule number 1. Central element. Iodine. Less electronegative. This one. In fact, the one which is less in number is always central, but we follow the rules. Iodine is less electronegative, central. Make the skeleton with 3 oxygens, right? Like this. Rule number 2. Rule number 3. Count the total valence electron. Total valence electrons. If there is a minus, you have to add one more. Yes, Kirtana, very good. 26. Rule number 4. Complete the octet of the most electronegative element with minimum formal charge. But children, remember here, there is one minus. So it means one of the oxygen is with this minus charge, one of the oxygen. If I make oxygen like this, if I make oxygen like this, if I make oxygen like this, here I'm giving you a trick also, like this. Can you check the formal charge on every oxygen here? You draw these 3 oxygens in your notebook with their formal charges. What's the formal charge in A? Formal charge, this equation. Sarayu, formal charge in A, 0. This oxygen is always central oxygen, is in the center. What's the formal charge in this? Gautam, you are doing wrong calculation. Valence electrons are 6, number of bonds are 2, lone pairs are 2 times 2, so it's 0. This is the oxygen with 0 formal charge and is not in the center. Yeah, double bond. Number of bonds, 2. In every bond, oxygen is giving 1 electron. No, you are counting the valence electrons of oxygen. Oxygen is with 6 valence electrons, is giving 2 electrons for making 2 bonds. And then is using 2 lone pairs for the remaining 4 electrons. So formal charge is 0, right? What's the formal charge here on oxygen? Yes, Rayu, very fast, very good. Children, anyone struggling with formal charge? So remember, if there is a polyatomic ion with negative like this, it means one of the oxygen is like this. One of the oxygen. One minus means one oxygen. Two minus means two oxygen. Some exceptions are there, but this is a really good trick. And other oxygens are like this. But before you do everything, you have to decide. Yes, yes, Gautam. Now look at this iodine. Do you think iodine can have expanded octet, children? Iodine can have expanded octet? Yes, it can. So let's start filling electrons. 26 electrons we have to fill. So what should I do with this oxygen? I can make a double bond. Don't worry about iodine. It can have expanded octet. It can make many bonds. Put 2 lone pairs. Octet is done. C8. Do the same thing with this oxygen. Double bond. 2 lone pairs. 8. But with this oxygen, don't make a double bond because I have to put this minus charge. So let it be like this with 3 lone pairs. And this is the one with minus 1. Now check how many are used. How many are used? See, you were ensuring 8 on every oxygen. This is 8. This is 8. This is 8. How many are used, children? How many are left? Use rule number 5. Where they will go? Where they will go? On the central atom as bond pair or lone pair? As lone pair, yes. Now check the formal charge on iodine. Oxygen you know already because we have practiced here. Check the formal charge everywhere. This oxygen is minus 1 here. See, whenever it is singly bonded with 3 lone pair. This is 0. This is 0. What's the formal charge on iodine, children? No, Gautam, again error. How many valence electron iodine has? 7. Out of 7, how many are used for bonds? 1, 2, 3, 4, 5. How many are there as lone pair? Only 2. 7 minus 7, 0, right? Iodine is 0. Is it okay? This lone pair on the iodine. Not don't count the lone pairs of the oxygen. On the iodine. Formal charges on the atom. Any questions, children? Ready for another? SeO4 2 minus. So tell me, how many oxygens you are expecting to be singly bonded with 3 lone pairs? How much negative is here? 2 oxygens, Aishwarya, 2. And the other 2 oxygens should be doubly bonded with 2 lone pairs. Remember I told you this? Oxygen with a double bond and 2 lone pairs. Oxygen with a single bond and 3 lone pairs. This is 0 formal charge. This is -1. Because you'll be doing so many Lewis dot structure with oxygen. Plenty of them. So if these things they settle down in your head like a trick, then you will never face any problem. You do it very fast. Oxygen with 2 bonds like this with 2 lone pairs. This is also 0. You can see oxygen like this. If you see oxygen like this, what's the formal charge on this oxygen? Suniti, what's the formal charge on this oxygen? Yeah, it is +1. Very good, Kirtana. Very good. Yes, Suniti, good. Aishwarya, good. This also can be seen. It's there, very popular. If you, when you are going to learn Unit 8, there you will learn hydronium ions, H3O plus. Where oxygen is like this, hydrogens are here. This is your H3O plus, children. Very popular ion. Okay, ready? So we are doing SeO4 2 minus. We call it as salinate, just like sulfate, salinate. So central element, follow the rules. Rule number 1, selenium. Make the skeleton means 4 bonds, 4 single bonds with oxygen. There are 4, right? 4 atoms. So just make it like this. Rule number 2. Count the total valence electrons. Total valence electrons. Okay, Gautam is saying 32. Just check him. Now complete the octet of the most electronegative element with minimum formal charge. So how many oxygens can have 0 formal charge here? So what should I do to make a 0 formal charge and to complete the octet of these oxygens? Make a double bond and lone pairs. Can you see 8? Can see 8 here, children? And check the formal charge using this equation. What about the next oxygen? Do the same thing. This is also 8. But what about this oxygen? How to complete the this oxygen? Because 2 of the oxygen should have -1. So what should I do on this oxygen? No double bond, Gautam. No double bond, single bond with 3 lone pairs. Yeah. This is, check the formal charge here. This is also 8. You can see 8 here. Can you see how I'm ensuring that every oxygen is with 8? Kirtana, this one is with -1. Sarayu and Suniti. What about this oxygen? What should I do? Should I make a double bond or put 3 lone pairs? And then minus here, right? This is also 8. Now check rule number 5. Aishwarya, I'm going to teach you a topic. We call it as resonance. So right now, the answer is doesn't matter. You can put double bonds anywhere. You can select any two oxygen with the double bond. But what the question has triggered another topic, resonance. So when I'm going to teach you resonance, then you will understand that we can put double bonds on any two oxygens. It doesn't matter because all oxygens are same. So I placed here, you can place between these two or between these two. How many are used, children? Okay, now I need to worry about selenium also. Can you tell me selenium can make maximum 6 bonds? How many bonds? Selenium? 6, because it can have expanded octet. Is this selenium with 6 bonds? I hope I'm not placing more than 6. Yes, so everybody is okay here. This is the Lewis dot structure of selenate. And check the formal charge on selenium. Okay, Ashwarya, again, Ashwarya is writing a question. Children, all of you, please try to understand this and try to answer if you know the answer. She is saying if it is hydrogen, then. So remember, Ashwarya, what is written? See rule number 1. Hydrogen will never make a double bond. It cannot share 2 electrons. It has only one unpaired electron. It can make only one bond. So there is no question of double bond on hydrogen and fluorine. Hydrogen, fluorine never make a double bond. They are always with single bond. Oh, that is the acids. Their hydrogen will not be the doubly bonded. So there is no comparison of oxygen and hydrogen. Hydrogen will be singly bonded. But as I said earlier, that you can put double bonds anywhere, which I'm going to teach you in the next class when I'm going to teach you resonance. At that time, I'll explain you. Okay? So it doesn't matter which oxygen is holding the double bond. Are we clear about selenate, children? See how fast we are making all these things. Let's make the Lewis dot structure of SF4. Very simple. Go very fast. Central element, skeleton, and remember, fluorine cannot have, fluorine cannot have more than one bond. So fluorine is always with one bond and try to recall. This is the skeleton. Count the total valence electrons. Fluorine never makes a double bond, is always singly bonded with. Complete the octet of fluorine. What should I do? Yeah, it's always like this. Whenever you see fluorine, just do like this. Aishwarya, is it clear? And then how many are used? How many are left? How many are used? See, you ensured the 8 on every fluorine. 2 are left. Where these 2 electrons will go, which Kirtana is already answering. These 2 electrons will go on the sulfur as lone pair. This is the Lewis dot structure of SF4. You can see all 34 are used. Check the formal charge on sulfur. You can check the formal charge like this also. Check here. A new way is more easier. Sulfur has 6 valence electrons. So it's using 2 here, 3, 4, 5, 6. All 6 used. 0 formal charge. This is also the way of checking. Like Rather than using this equation, you can do this. That total valence electrons 6. 4 are present in 4 bonds. 1, 2, 3, 4. And 2 as lone pair. So total 6. 6 minus 6, 0. Fluorine is also 0, children. 7 minus 7. Check here. 1 here and 6 here. 7 minus 7, 0. So fluorine is also with 0. Ready for another? CO3, 2 minus. Central element. Central element. Skeleton. There are 3 oxygens. Total valence electrons. How many oxygens are singly bonded? How many oxygens are doubly bonded? Only 1 oxygen is singly bonded. Oh, sorry. Only 1 oxygen is. Oh, see, 2 minus. Is it 24? Yeah, it is 24. Gautam, what error we are doing? Kirtana is correcting the number of valence electrons. She is right. You have to add this 2 also. Sarayu, no answers? Sarayu and Suniti. Suniti, you are understanding everything? Suniti, are you there? Sarayu, are you there? If you leave your chair, Suniti and Sarayu, you were not there in the first class. If you are not near your computer, you want to drink water, want to take a break of 1 minute or so, you have to inform me. Suniti is saying she is getting wrong answer, so let's calculate it. Every time we are going to calculate now. How many valence electrons of carbon, Suniti? How many valence electrons? 4 carbon. How many on oxygen? Answer it. So how many oxygens are there? 3. 3 times 6. Each oxygen 6. And then this 2 minus. This 2 minus means extra 2 electrons. See, it's written here, add 1 for each negative charge. How much total? Now my question is, out of 3 oxygens, how many oxygens are with single bond and how many oxygens are with double bond? Take care that carbon can have maximum how many bonds? Only 4. It cannot have more than 4 bonds. So taking care into account all these things, how many double bonds are present here in these 3 oxygens? Only 1. Only 1 oxygen can hold the double bond because carbon is done. It cannot make more double bonds. And 1 oxygen with the double bond. Now complete the octet of this oxygen. How many lone pairs on this oxygen? Yes, Suniti? Kirtana? Is it confusing? Aishwarya, you're not answering. 2 lone pairs. Aishwarya, you're there? Can I make a double bond here, children? What is the reason, Gautam? Because in that case, carbon will become expanded octet, but carbon cannot have expanded octet. It can have maximum 8, and we are done with 8 on carbon. Carbon is done. So don't make a double bond. So how many lone pairs on this oxygen? 3. How many lone pairs on this oxygen? 3. Check the formal charge on every oxygen. Check the formal charge on every oxygen. No, I said the other way round. I said if it is a polyatomic ions, the charge on the ion is equal to the number of oxygens which are singly bonded with 3 lone pairs. Because negative formal charge is when oxygen is like this. I said this. Aishwarya, you're getting it? This oxygen, I've written it 3 times. This oxygen is -1. This oxygen, doubly bonded oxygen is 0. Okay, so everybody is giving me the formal charge on the oxygen. This oxygen is -1. You can check it. Use this equation. Check. Oxygen has 6 valence electrons. It's using 6 here, these 6, and 1 here. 6 minus 7, -1. Same here. 6 here and 1 here. So 6 minus 1. So this is also -1. Here it's using exactly 6. 6 minus 6. What's the formal charge on carbon? Carbon is 0. It has given 4 electrons and it's using 4. 1, 2. For a double bond, they will use 2 electrons like this. Like this. So we are understanding this story of the Lewis-Dot structures. Ready for another example? Okay, the other example which is here. P can have expanded octet. So first you think about this P. Expanded octet, yes or no? Yeah, okay. Maximum how many bonds P can make? No, Gautam. How many valence electron P has? 5. So 5 bonds. Okay. So follow the first rule. Central element. Skeleton means make 4 single bond with 4 oxygen. I'm following the rules. Now, Suniti, total valence electrons are P's 5. Each oxygen is 6. And this 3 minus means you have to add plus 3. It is 32, right? Yeah. Now, how many oxygens are doubly bonded? How many oxygens should be singly bonded? Yes, only one oxygen doubly bonded. Can you check after making a double bond, P is done? You can see P is done. All five bonds are there. And you put a 2 lone pair. Remaining 3 oxygens are singly bonded. Put the formal charge on each oxygen. Put the formal charge on each oxygen. And this is the Lewis dot structure. Check how many are used, how many are left. Rule number 5. You ensure that every oxygen is with 8. So you can check like this. 8, 8, 8, 8, 8. 4 times 8, 32. All used. No lone pair on P. P as it is done. You can see P has used all its electrons. All 5. 1 here, 2 here. P is 0. Nothing left. Okay, ready for another? Make the Lewis dot structure of SO2. Central element. Now there is no formal charge. Central element, sulfur. Skeleton, total valence electron unity, 18. Is she right? Kirtana is right. Suniti, just check. Aishwarya, Sarayu, no answers? No, okay, she's right. Okay, good. Now, complete the octet of the oxygen. Rule number 4, sorry. Complete the octet of the oxygen first with minimum formal charge. So you know how oxygen is very happy. Oh no, Gautam, no. If I put 3 lone pairs on the oxygen, then the formal charge is -1. But the rule says minimum, no formal charge. Yes, make a double bond. Sulfur has no objection. Sulfur can have expanded octet. Check here. It can make many bonds. It can hold many bonds. So sulfur has no objection. Make a double bond here. And oxygen is happy, 0. Can I make this oxygen also happy? Yeah, no problem. Sulfur is okay. Sulfur is okay, children. Now check how many are used, how many are left. Where these two will go? As a lone pair on the sulfur, right? So that's the Lewis dot structure of SO2. Check how all are used now. What's the formal charge on sulfur? Sulfur has 6 valence electrons. How many it has used? 1, 2, 3, 4, 5, 6. All 6 are used. Sulfur is happy, oxygen is happy. This is the Lewis dot structure of SO2. Exactly same Lewis dot structure will be for SeO2. They're in the same family. Exactly same for TeO2 because their valence electrons are same. Aishwarya, how many electrons are there around sulfur right now? How many electrons around sulfur? No. Come on, dear. It's 10. You are counting the valence electrons. Now, when I'm counting the total number of electrons around sulfur in the molecule, I'll count this as a pair. Now check. 10. You were just counting the blue ones, but they are the one I was counting for calculating the formal charge that sulfur has given 6, how many it has used. How many it has used. But when I say how many electrons, total electrons around sulfur, then you are going to count the bond pair and the lone pair. Yes. See, children, all these molecules will have the same Lewis dot structure because they are in the same family with same number of valence electrons, 18, all of them. So same Lewis dot structure, right? So if you see the formula from the same family, like if I give you ClO4 minus, then BrO4 minus, and IO4 minus, they all have the same Lewis dot structure. Are you interested in making for this BrO4 minus? Ready? Let's make for BrO4 minus. Check Br. Any objection for expanded octet? Br can have expanded. Yeah, okay, good. How many maximum bonds Br can make? And there is one minus. So how many oxygens are singly bonded around Br? Singly bonded. There is only one minus. This number indicates singly bonded. Yes, Suniti, you are right. Sarayu, no answer? We are in the center. Make the skeleton. Sarayu, start giving answers, please. And then make double bond with 3 oxygens. Put 2 lone pairs to make the formal charge 0 and to complete the octet. But 1 oxygen is with 3 lone pairs and a negative formal charge. Check total valence electrons. Br is 7. Oxygen is 4 times 6. And then this minus means plus 1. So I'm sure it's 32, right? It's 32. Check how many are used, how many are left. You can check like this. This is 8. All are used. Yes, all are used. So check the formal charge on Br. Br has 7 valence electrons. It's making 7 bonds, 0. Srayu, are you there? You're not responding. So you are not answering. You are not interested in answering. I know that you know the things, but still, participation, just you know that is um, it's very important that you answer here because I'm not using any camera. I'm not asking you to use a camera. If you don't want to answer, then start using your camera so that I can see that you are awake and you are on your chair and you are learning, right? So, children, those who are not interested in answering in the chat, they have to use their camera then, which I'm sure you don't want. So, it's better to answer here in the chat. Okay. So that was the Lewis dot structure of BrO4 minus. Exactly same will be there for ClO4 minus. Exactly same will be there for IO4 minus. Children, can you tell me I don't have FO4 minus? F is also in the same family. So why we don't have FO4 minus? FO4 minus does not exist. And here comes, yeah, very good. Very good. Fluorine makes only one bond. Here, these elements are making 7 bonds. That's not feasible with fluorine because fluorine cannot have expanded octet. Perfect. Very good. Okay. Now I'm giving you one more structure, but we have to be very careful with this. NO3 minus. Check nitrogen. Do you think nitrogen can have expanded octet? Gautam is saying yes. Who is going to correct him? He's wrong, right? Yes, Gautam is wrong, children. Why? Gautam is still wrong. Why? Okay, Sreshta explanation is also wrong. Sarayu, are you interested in explaining why they are wrong? Do you think 2s, 2, 2p3, do you have empty d orbital here? No excited state for nitrogen. It has only 3 unpaired electrons. So nitrogen cannot have more than 8. Nitrogen cannot have more than 4 bonds. Maximum it can go only for 8. That's it. It cannot go for more than 4 bonds. Srayu, am I right? Sarayu, please don't make me call your name again and again because it's going to slow down the class. I don't want to slow down the class. I'm sure that all of you want to learn a lot of things in less time. But everybody is writing, isn't it? They are writing brief. Keep answering here. Okay, this is my habit, children. I'm very, you can say that, okay, she's always calling the name, she's always troubling us. But I cannot teach if you're not responding in the chat. I find it very difficult. I got scared. My student is listening or not listening. Is he or she understanding or not understanding? That's the problem with me. Yes, Gautam, but it can make four bonds also. See here. You remember I gave you the example of NH4 plus. So how many bonds nitrogen is making there? Four. But no problem. Nitrogen can exist with four bonds and there is a formal charge plus. If it makes four bonds, then it has a formal charge plus one. But it cannot make more than four. That you have to ensure. Is it okay, Gautam? Okay, so let's make the Lewis dot structure of nitrates. Central element, nitrogen. Make the skeleton. Rule number two, three oxygens. Complete the octet of the oxygen. Rule number, oh no, rule number three. Count the total valence electrons. Yes, all of you, please give me the total valence electrons here. Yeah, 24. Good. Aishwarya is saying one single bond. So what do you want to say, Aishwarya? Two double bonds? But if I make two double bonds, then nitrogen is killed. Nitrogen is more than eight. So only one double bond and two single bonds. You're understanding this? So complete the octet of this doubly bonded oxygen. Complete the octet of this. Don't make a double bond now. Complete the octet of this. Check the formal charge on all of them. Check how many are used. Rule number 5. How many are used? All are used, right? So nothing for nitrogen left. Now check the formal charge on every element. This oxygen is 0. Yeah, Kirtana, no problem. This oxygen is -1. This oxygen is -1. What's the formal charge on nitrogen? Nitrogen. Shrestha. Aishwarya. Both of you are wrong. You didn't do calculations, Shrestha, Aishwarya, and Sarayu is still not interested in answering. Sarayu, wrong. Sarayu, are you giving me for nitrogen? Okay. Check nitrogen again, all of you. 5 valence electrons and 4 are in the bonding, no lone pair, so it is +1. And that is the reason nitrate has 2 oxygens with -1, but still the net formal charge is -1. Why? Because if you add this -1, this +1, this -1, what is the net charge? -1. Yeah. Yes, yes, yes. Are we good with this? Okay, so that's the Lewis-Dot structures. Okay, children. After learning Lewis-Dot structures, though I know that we are left with 10 minutes, but I just want to tell you that if you do Lewis-Dot structure accurately, this is just the starting of making it. Today we've finished many of them, but this is just the starting. After Lewis-Dot structure, you are going to decide the EPA, electron pair arrangement. If you do error here, then your EPA will be wrong. Yeah, Suniti, no problem. And this EPA will decide the molecular geometry. EPA means, I'll give you the full forms. And the molecular geometry will decide the IMF. Is unit 3. So EPA and the molecular geometry is the part of learning of VSEPR. But if only problem is with the Lewis-Dot structure, you will do error in the Lewis-Dot structure. If you are not a good student, then error will be there in the Lewis-Dot structure only. After that, VACPR, EPA, IMF, they are very simple. They are not tough. But please understand, if there is error here, then there is error in all these. It becomes 0 marks. So what is more important? That you draw the right Lewis-Dot structures with correct formal charges, which I feel that all of you have understood so well. Now write down the full form of EPA. EPA is electron pair arrangement. Yeah, thank you very much, Shrestha. Some teachers, they call it as EDG, electron domain arrangement, EDA. They call it as EDA, electron domain arrangement. That's right. You can call this one as anything. You have to just understand the concept. Electron domain arrangement. In electron pair arrangement, you will be checking the bond pair. Now you know the bond pair and lone pair. In fact, the bond pair word, I will be replacing it by atoms. Rather than bond pair, I'll write atoms because atoms are the one which are going to make bonds. Electron EPA is determined by this. Yes. Aishwarya is saying in place of EPA, she's saying EDG, electron domain geometry. Yes, it is the same thing, Aishwarya. Then from the EPA, you're going to decide the molecular geometry. Which I'm going to say MG all the time. This is decided from EPA only. Only thing is that you are not going to consider lone pair and you will decide from there. Is it okay? Any error in the Lewis-Dot structure, your building will collapse. One big free response question of AP chemistry will become totally zero. So the most important thing is draw the right Lewis-Dot structures. Okay, now I'm going to make you understand how we are going to use this. This is another topic which you will do after doing the VSEPR, hybridization. Okay, Suniti. Let's draw the Lewis-Dot structure of water to understand EPA, molecular geometry, VSEPR. Water. Central element. Hydrogen can never be the central element. Yes. Skeleton. Total valence electrons. Hydrogen is done, children. Hydrogen is done. So pay attention to oxygen. Oxygen complete the octet. Two lone pairs. Yes. Check the formal charge on oxygen, hydrogen. Check the formal charge. Everybody is zero. Water is very stable. Yeah, everybody is zero. Hydrogen zero, oxygen zero. Very good. Now, pay attention to the central atom. And we are going to decide EPA, electron pair arrangement. Can you tell me how many atoms and lone pairs are there on central oxygen? In total, 4. Now, it means there are 4 bundles of electrons. I'm making the bundles here. Around the oxygen, there are 4 bundles of electrons. This is one bundle. This is another bundle. This is another bundle. This is another bundle. These bundle of electrons, they love each other or they hate each other? What do you think? Are they going to attract or repel? They hate. If they hate, they want to go away from each other. Am I right? Far away to minimize the repulsion. When you have 4 groups around the central atom, 4 groups, these are, I'm going to call them as groups now. When you have 4 groups around the central atom, then nature gives you a tetrahedral arrangement like this. Tetrahedral. So what is the EPA for water? EPA is tetrahedral. 2 are occupied by lone pairs like this. And 2 are occupied by, these are tetrahedral corners by hydrogen. This is EPA. Now how to decide the molecular geometry? Molecular geometry is because of the bonds, not because of the lone pairs. So these bonds are missing. There is no bond here. There is no bond here. Put these lone pairs in the orbitals of oxygen like this. What is visible to you children now? What is visible? Bent. Bent, angular. Can you see like an angle? You can call it as bent or angular. That's the molecular geometry of water. Can you see how I started with water? First, I made the Lewis dot structure. Then I counted the lone pairs and atoms around oxygen. Then I decided the EPA. And then I removed the bonds of the lone pair to see the molecular geometry. Yes, Gautam, you're right. Because lone pairs will not make a bond. Molecular geometries, it's just because of the bonds, the angle and everything is because of the bonds. And now, children, I think we are left with 1 minute. I just want to show you that PDF which I shared with you. So we'll discuss the different types of geometries permitted by nature. You must take a printout of this before the next class. Next class will be full of questions only. So the same equation formal charge I will be using in the next class also. We'll write the Lewis dot structure the way we did today. But after that, with every structure, we are going to decide the EPA. We'll decide the molecular geometry. We'll decide the molecule is symmetrical or not symmetrical, dipoles are cancelled or not cancelled. And based on this, we'll decide the IMF. Hybridization, this one, we can do after learning all the EPAs. So we'll do hybridization maybe next to next class, right? So next class is going to be very uh, like full of question, full of practice, very important class. So join at the right time. So see you in the next class, children. If you have any questions, you can stay back. You can bring questions from your homework also in case you have some homework problems. See you then. Bye. Bye-bye. Unit 3, I'm starting here only. Like after doing this, when we are doing the EPA, we'll be discussing the molecular geometries and the IMF. IMF is a part of Unit 3. But I will start Unit 3 after finishing the rest of the Unit 2. So I'm not going to jump on Unit 3 straight away. So first we'll finish everything, the resonance, and there are many more topics in Unit 2. Only then I'll start up Unit 3. But yes, side by side, we are doing some part of the Unit 3. Yeah, please. No,
So
unmute. Mhm.
so I have one question. In class, they'll give us like different versions of the same molecule, and based on the formal charges, we have to like know which one is the most stable or unstable. Can you like show like an
Yeah,
example how to do that?
yeah, that's a very good question. You know that we were making the Lewis dot structure, and there was written very clearly that you have to make it with minimum formal charges. The Lewis dot structure should be with minimum formal charges. If you
Yeah.
make extra formal charges, like for example, if I give you this SO4 2 minus, we made this structure if you remember.
Yes.
But if I make it like this, like this. Now the formal charge on each oxygen is 0. Oxygen is very happy. But what's the formal charge on sulfur?
Um, I think
6
it's
minus 8 minus
yeah,
2.
-2.
It's very unstable because
Yeah.
oxygen is more electronegative than sulfur. So who should hold the formal charge? Oxygen, not the sulfur,
Yeah.
right? So that is the
Yeah.
reason oxygen will get the negative charge. So this structure is unstable. So what was the stable structure? The one which we made in the class today. That two
Okay.
oxygens are with single bond like this. So when you see that the molecule, the ion is holding more formal charges, extra formal charges, or if the negative formal charge is on less electronegative atom, then you can predict that, okay, this is unstable, right?
Okay. Yeah. And then another thing is like when we're checking the like the energies, like the lattice energies, we in class we said like in our school we said like charge trumps distance. So if the even if like distance is like I don't know, closer or longer, if the charge is like long increasing, the force will
Like,
change.
see,
Yeah.
this is based on Coulomb's law that F equals to K, the constant, Q1, Q2 over R squared.
Okay.
Q1 and Q2 are the charges. If charges are
Okay.
more, attraction is more. If attraction is more, lattice energy is more. You need more
Okay.
energy to break the lattice also, right? So Q1
Yeah.
and Q2, so first difference is charges. And if you see the difference in charges, you are ready to answer it. But if charges are same, then you have to see the distance or separation of charges. R, separation of charges, right?
Okay.
Like for example, if I give you NaCl and NaBr, charges are same, right? But
Yeah.
now I will compare Na plus is also same, so don't compare. Compare these two. Now, which one is bigger? Br minus. Down
Um,
the group, right?
yeah,
So it means which one has stronger attraction? The smaller one. More closer to
yeah,
each other, more attraction. R is in the denominator, you can see. So it means
yeah.
the lattice enthalpy of NaCl is more than that of NaBr. It means the melting point of NaCl is more than NaBr, like this, Aishwarya.
Okay. And does that also change the solubility? Because
Yeah,
if
yeah, definitely, definitely. It changes
okay,
the solubility. Because if lattice enthalpy is more, solubility is less.
okay,
Because you have to break the lattice to make it soluble.
okay. So in this question, like you have one element that's the same Na and in both of them. What if you had a question where it's like totally different elements? Like how would you
Yeah. Like for
know?
example, Al2O3 and Na2S. First of all, they will not give you very confusing examples, right? Because
Yeah.
all the data is not there with us. But somehow something which we can compare easily, we can check that. This one. What's the charge on aluminum here? +3. What's the charge on oxygen here? -2. What's the charge on sodium here? +1. Sulfur, -2. You can decide straight away. Straight away decide from the charges. There is no need of looking into the size because charges is the dominating factor. You can see
Okay.
here, charges are more. So this one has stronger latex, stronger attraction, melting point high.
Okay, so if if it's more like if one of them was like a positive charge of 1, but it like or another one is positive charge of 2, then the 2 would be like more, right?
Mm-hmm. Yes, like
Okay.
if I want to compare Na2S with MgO, this is +2, this is -2. So the strongest lattice is of Al2O3, highest melting point, then MgO, and then Na2S.
Okay. So it has to be in order from like so lowest would have like least like negative charge and highest would have positive charge.
No, 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 it's not that. It's the amount of charge. Whether it is negative or positive, it doesn't matter.
Okay.
Okay, it can be negative, it can be positive. It's the amount, the number. Like
Okay.
if I give you Na3P and Na2S, Na3P, Na is plus, P is 3 minus, Na is plus, S is 2 minus. So which one has stronger latex? This one. Because
Okay.
three is more.
Okay, so we don't need to like add up +3 and -2 in aluminum. We just look at like the amount of charges and based
Yes,
on
yes.
that. Okay.
You can see the difference or more charges here. More plus, more minus. More plus, more minus, more stronger attraction. More stronger attraction, more stronger latex. More stronger latex, more difficult to break. More difficult to break, more higher melting point, boiling point, all these things.
Okay.
That is
Okay.
unit
Thank
3.
you.
Yeah. Okay, now Aishwarya, I think I must tell you that here we are following your order. I skipped unit 1 because I know that most of the schools are unit 2 and 3.
Yeah.
So, but now I have started unit 2. So my aim will be to finish unit 2 thoroughly and then go for unit 3. So maybe I
Okay.
will not be exactly aligned to your school,
Okay. But
right?
if I have like any unit 3 questions, can I ask it?
Yeah, you can ask unit 8 question, unit 9 question, any question, but before the class or after the class,
Okay.
right? Okay, and
Okay.
I have a forum also. I don't know whether you are aware of that.
On the Chem Topper website?
Yeah, let me show you that also. You can, okay, one second. I'm getting the forum here. I'll give you the link.
Okay.
on I'll ask admin to make a link and send it to all of you. This is the forum. If you have any questions, which let's say you have plenty of questions, you have classes twice a week only, right? So
Yeah.
if you have questions in between, then you post it here. But Aishwarya, the way I'm teaching you today, and you are posting a question, somebody is posting a question, I cannot answer because I'm teaching, right? So
Yeah.
don't expect that I'll answer it immediately. I'll answer it in your midnight, or by morning you can see the answer. So there will be a
Okay.
time gap, right?
Okay.
But you can place as many questions as you want here. See, all these are AP children,
Okay.
right? Those who are good students, I've seen that they're asking plenty of questions during the class, after the class, even they are very active on the forum.
Okay. And so for
Right.
the on the like the platform, the ChemTopper platform, there's like lots of tabs. Like which quizzes do you want us to do?
The quizzes on my website.
Yeah, like the with all the resources and stuff.
Yeah. Unit 1, you have not started with me, so leave it. But you can start doing Unit 2. So I'll be
Okay, so
sending you this homework also on the. But have you added me as your contact in your mobile? Because most of the messages which I will be sending you will be the broadcast messages. And broadcast message you can receive if I'm your contact.
okay.
So I don't know whether I'm in your contact. You have added me as your contact in your mobile
I don't know. I don't think so. Do I add it in WhatsApp or
on WhatsApp.
okay.
So admin will send you a message. He will check and he will let you know that whether you are receiving my broadcast messages. Otherwise, I'll give you the quizzes from here after doing the class. I'll ask you to do all these quizzes. Like you can do this types of chemical bonds. This we did in the
Okay.
last class, if you remember.
Okay, so the red ones are the quizzes.
Yeah, read one the quizzes. These are the notes.
Okay.
You can read them. This is the Coulomb's law, which I was telling you.
Okay.
Here, see, you see. So half of the unit 3 will be done here only. All the
Okay.
questions which you are asking from me, as it is going to do as this particular thing, where it is, structure of ionic solids. Here I will be teaching you this only. The lattice, the attractions, the melting point. See, ionic lattice. You were using exactly same word. Lattice energy. See, this is what you were learning from me just now.
Yeah.
It's the part of unit 3 as well as unit 2. So unit 2 and 3 are very overlapping. Okay.
Okay.
So don't worry. We'll cover everything. That's why AP is very vast,
Yeah.
but it's not difficult. I hope today when I was teaching, everything was going fine with you.
Yeah. Yeah. I understood.
Okay, good. How did you come to know about my website?
My father was like looking at it, so he found it.
Okay, Google search. Okay. In case anyone looking up for classes, I have some vacancies in the Saturday, Sunday classes. Though they have already started, they are already on group on the unit 2 and 3. But recordings are there in case any of your friend is still struggling and are looking up for some tutors for AP chemistry, then please do let them know about me.
Okay, thank you. Yeah, I think that's all my questions. Thank you.
Welcome. Bye bye.
Bye.